Hi friends, welcome to my YouTube channel Little Master and Family. I am Amal Sobin. Today I came with a very useful video for students studying in 4th, 5th and 6th. I am going to teach you about HCF and LCM. In the previous year when I was studying in school, in the Teachers Day program, we had a program like the students will be the teachers and the students will teach. So I got a specific subject from my maths teacher to teach about HCF and LCM. So at that time when I taught my friends, they told it was really useful, really helpful, and they understood it very clearly. So I thought I'll share with my YouTube friends too. So today I want to teach you about HCF and LCM. I will also teach you by different methods. So let's start the video.
HCF and LCM. But before studying about HCF and LCM, we need to know some other basics. So for the basics, we want to know about factors and multiples. So let's carry on to factors. So factors are any numbers that will divide another number evenly without any remainder. So for example, like 3 and 6 are the factors of 12 because 12 divided by 3 is 4. So they exactly divides without any remainder. So 3 can be a factor of 12. And also 6 is a factor because 12 divided by 6 is 2. So let's have another example. So let us find the factors of 24. So for finding a factor by multiplication, it's just simple. We want to just check by multiplying which all numbers we will get the number we want. So for example, I wanted to find the factor of 24. So 1 into 24. So we will get the answer 24. So 1 can be a factor of it. Then 2 into 12, 24. Then 3 into 8, 24. 4 into 6, 24. And 6 into 4. But now we have to stop here because already we have found 4 into 6. So next it is coming 6 into 4. So the numbers are coming reverse again. So if we move on again, we can see just it will come reverse of the numbers which we have found already. So if we if we find any numbers that are coming reverse or coming the same as we found before, then we have to stop there and we have to write down the numbers. So first of all, we got 1 into 24. So 1 and 24 can be the factors. Then next 2 into 12. So we can write 2 and 12. Then next 3 into 8. So 3 and 8 can be the factors too. Then 4 into 6. So 4 and 6 can be the factors. So that's all. We can find the factors of any number easily by this method. I hope you understood what's factors, and now let's carry on to multiples. Okay, so multiple is any number obtained by multiplying other numbers together. It's very simple that factors because it's just easy. Multiples of 3, that means we want to just multiply it and get the numbers. So the multiples of 3 are 3 can be a multiple because 3 into 1, 3. So it can be multiple. Then 3 into 2, the answer is 6. So 6 can be a multiple. So for example, I want every multiples of 3. There are unlimited multiples, but factors are limited. Okay, so next is the prime numbers. Before starting to learn about HCF, we want to also learn about prime numbers. So prime numbers means a number greater than 1. So what can we understand from this? 1 cannot be a prime number. Okay, so a number that is greater than 1 which has only 2 factors. So we studied about factors. So any number that is greater than 1 and only have 2 factors, and that is the 1 and the number itself is called prime number. So what is a factor? A number that divides another number without a remainder. So a number that is greater than 1 and which has only 2 factors. So let us take an example. 2 is a prime number. So let us check for 2. Only 1 into 2 we can obtain 2. So 1 is a factor and 2 is a factor of it. So 1 and the number itself. So if we get those numbers, it can be counted in prime numbers. So let us find some examples of prime numbers. So those numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and etc, etc, because the prime as numbers are unlimited, and prime numbers are also unlimited, so we can't count every numbers together now, so we are just telling the few numbers. And there's another important thing: every number is a product of the prime numbers. Let's study about prime factorization. We have studied about prime numbers, so and also remember something: prime factorization can only be done by prime numbers. Okay, so division in prime factorization there are commonly two types of methods: division method and factor tree method. Let us study about division method first. So for doing division method, we have to draw a line like this, and after that we have to write the numbers which we wanted to prime factorize. So now I wanted to prime factorize the number 48. So we have to check by which prime number this 48 can be divided. Okay, so let us check with the smallest prime number first of all. Which is the smallest prime number is 2. So 2 is the lowest prime number. So let us start with 2. Let us check, is 2 divisible by 48? Yes, it is. So let us divide and check. When we divide, we will get the answer as 24 without any reminder. Then it is possible. So if it is coming like that, let's write it down. 24 down. Okay, now we wanted to divide 24. So for dividing 24, let us check with the lowest prime number again. So 2 is possible. So let's move with 2 again. So when we divide 24 by 2, we will get 12. Now let us check with 2 with 12 also again, because it's the lowest prime number. So 2 is possible by 12. So let us write that down. So we will get the answer as 6. Now in this 6, let us check if it is divisible by 2. Yes, it is possible, but it's also possible by 3. But it is not required to always write from the lowest prime number. You can write in any prime number, but if it's divisible only. I'm doing with the lowest prime number always, so you can understand it easily. So 6 is divisible by 2. So when we divide it, we will get the answer as 3. Now we have to stop here because we got 3. 3 is a prime number, so it can't be divisible. So we can only divide 3 by 3 itself. So we will get the answer as 1. So if we get it, we have to stop. If we find any prime number at the ending, then we have to stop there. Now let us check the answers. For checking the answers, we have to write down every numbers in the left side. So in the left side, we have got 4 2s and 1 3. So when we multiply and check them together, if we get the answer which we have done the prime factorization, then your problem is correct. So we were prime factorizing 48. So let us check if it is correct. So 2 into 2, 4. Then 4 into 8, 4 into 2, 8. 8 into 2, 16. 16 into 3, 48. So it is those are correct. So that means our prime factorization was successful. Now we studied about division in prime factorization. Now let's check with another method, that is factor tree method. Okay, so for doing factor tree method, we have to write the number which we wanted to factorize. So let us take 60 for an example. Now we have to check how 60 is possible to be divided. So 60 can be divided by 6 into 10. So let us write those numbers and give it a line like this. Okay, so 6 and 10. Now let us check with how can 6 be obtained by multiplying. We can get 6 by multiplying 2 into 3. So when we multiply 2 into 3, we will get the answer as 6. So we can write both 2 and 3 down and give them a line from 6. And now we cannot go by 2 because 2 is a prime number. So it cannot be divisible by any number. So we have to stop there. Now let us check with the another one. 3. 3 is also a prime number. So we have to stop there. Now we were doing in 6 currently. Now let us check with 10. So how is 10 possible? 5 into 2. So let us write 5 and 2 and give it a branch. Now let us check with 5. 5 is not possible because 5 is a prime number. So we have to stop there. And let us check with the next number, which is 2. 2 is also a prime number, so we can stop there. So as we did before, we want to calculate every prime numbers which we got. So we got 2 as a prime number, 3, 5 and another 2. So 2 into 3 into 5 into 2. So when we calculate them, if we get the answer which we were prime factorizing, then our problem is successful. So let us check. So 2 into 3, 6, and 6 into 5, which is 30, 30 into 2, 60. So our prime factorization by factor tree method was successful. Now we have learned the basics before learning HCF. Now let's start learning HCF. So what is HCF? HCF means highest common factors among the numbers which we have selected. So the full form of HCF is highest common factor, or it can be also GCF, which stands for greatest common factor. So let us find the HCF of 24 and 36. So for finding them, let us write all the factors of the numbers which we have selected, 24 and 36. So let us write the factors of them. So factors of 24. As I told you the method how to find the factors of any number, you have to apply the method and find out the factors of the numbers. So the factors of 24, those are 1, 2, 3, 4, 6, 8, 12 and 24. And the factors of 36, 1, 2, 3, 4, 6, 8, 9, 12, 18 and 36. Okay. Now the next step is finding the common factors among them. Common factors means the factors which have repeated among them. So in the factors of 24 and in the factors of 36, which numbers are common there? So we can find 1 is common among the factors of 24 and 36. So let us underline 1. Now 2 is also repeating, so it's a common factor. Then 3, it's 2 repeating, so 3 can be also a common factor. 4 is also repeating, 6 is also repeating, 12 is also repeating, and that's all. So we have found 6 common factors in the factors of 24 and 36. So let us write those factors down. So 1, 2, 3, 4, 6 and 12. So those are the common factors which we found. Now we have to find the largest factor in them. So from the common factors which we found, the greatest number that means the greatest common factor among them is 12. So the largest factor or the highest common factor among them is 12. So the HCF is 12. I hope you understood it. So that was really easy. Now let us check finding the HCF in another method. Now let us find HCF by prime factorization method. It is also easy as I told you before, but let us take 3 numbers now. So I'm going to take 48, 54 and 120. Finding the HCF of these numbers by prime factorization, we have to prime factorize every numbers which we have selected. I have selected 48, 54 and 120. So we have to prime factorize those numbers. After we have done prime factorization of the numbers, now let us take them, take the answers of them. So the prime numbers among in this the prime factorization of 48 are 2, 2, 2, 2 and 3. Now for 72, so the prime in the prime factorization of 72 we have found 2, 2, 2, 3 and 3 as the prime numbers. And in 120 we have found 2, 2, 2, 3 and 5 as the prime numbers in the prime factorization of 120. Now let us write them down. So 48 means 2 into 2 into 2 into 2 into 3. So we will get the answer of 48. If I want to revise, I will just tell. So 2 into 2, 4, 4 into 2, 8, 8 into 2, 16 and 16 into 3, 48. And that's the same method for 72 and 120 also. Now let us circle the common multiples among these. So let us how much numbers we are taking, we must find the numbers that much. So now we have took three numbers, so we have to check if the number is repeating in those three also. So 2 is repeating in both these three numbers. Again another 2 is repeating in these three numbers. So let us take them. Again it is 2 is repeating in these three also. So now we have found 3 2s, and let us check for another 2. But now we can't take 2 because there is only one 2. If we want to take a common multiple, we must have 3 numbers. So if there is only one, then we can't take it. Now let us check for another ones. So 3 is coming. So let us take 3 also. 3 is coming thrice. So 3 can be also countable. And also remember something, it is not required to always underline the numbers straight or vertically or in the same line, but we can also do it like diagonally also. And let us check for another numbers. So 3 is coming only once, so it's not countable. Then 5 is also coming only once, so it's not countable. So we have got 4 common multiples. So they are 2, 2, 2 and 3. So we shouldn't count like we got 2 3s, another 2 3s and another 2 3s and 3 3s also. But how much we have counted in them, we have to just take the one number of them. So we have found 2 into 2 into 2 into 3. So the answer is 2 into 2 4, 4 into 2 8, 8 into 3 24. So the HCF is 24. So we can find we can find the HCF by prime factorization by this method. Now let us find HCF by division method. Division method is little bit complicated, but I will teach you easily. So for an example, let's find the HCF of 391 and 527. So it's just easy like doing division. So as we do division, we have to write the line, and we have to take the divisor as the smaller number. So the smaller number among these between these two are 391. So it will be the divisor, and the dividend will be the larger number. So the larger number is 527. Okay, now we have to divide them both. So 391 is divisible only one time in 527. So let us write that down. So when we divide them, and after we have divided, let's subtract them. So when we subtract, we will get the answer as 136. So the quotient was 1. Now let us carry on with 136. So then next the divisor will be the remainder which we got before, and the dividend will be the divisor which we used before. So the divisor which we used before was 391. So 391 will be the next dividend, and the next divisor will be the number which we got as remainder. So the remainder was 136. Now let us divide them both. So 139 and 136. When we divide them both, how much times will 136 included in the 391? 2 times. So 136 into 2 is 190, 272. So let us write 272. So 136 will go 2 times, so the answer is 272, and we have to subtract them. When we subtract them, we will get the answer as 190. So we have to continue this process until we get 0 as the remainder. So when we got 119, now this is the remainder which we got. So when we got this as the remainder, so this will be the divisor. Now the dividend will be the previous divisor. The previous divisor was 136, so let us write that down. Now we have to divide them both. So 119 will only go inside 136 one time. So 1, and we have to write it, then subtract. When we subtract, we will get the answer as 17, and we have to continue this process again. So 17 will be the divisor, and the previous divisor will be the dividend. So 119 will be the next dividend. So when we divide 17 in 119, it's only possible to include it as 7. So when we multiply 17 by 17 into 7, we will get the answer as exactly 119. So let us write 119. So when we do that, when we subtract it, we will get the answer as 0. So the remainder here is 0. So we have finished our division, and the HCF will be the number which we got as the previous divisor. So the previous divisor, that means before we got 0 as the remainder, which divisor was we using, that divisor will be the HCF here. So the last divisor which we had was 17. So 17 will be the HCF.
I hope you understood the video. If you have any doubts or want any help related to this video, please comment, and I will be always ready to answer your question. This video is divided into 2 parts of HCF and LCM. The next part will be of LCM, so don't forget to watch that video also, and I will upload it as soon as possible. So please subscribe, like, share and comment. Bye.